Howdy, and welcome to episode 2 of Math Boost Camp, How to Build Conceptual Understanding. By the end of today's session, you will know the concrete, pictorial, and abstract model and each of the 3 stages with a corresponding example. It is my hope that this can boost your math understanding and help your students thrive as you facilitate a more successful math environment in your classroom. Let's get started. When somebody else moves, what is your first reaction? Being a toddler mom, the first thing I think of is my kids being rude. Can you relate? When you hear the word move, that is usually your first response. But what if I told you that there was a house burning down and there was a man in a fire suit yelling move? Would you have a different opinion? I sure would. See, that word changes meaning based on its context. And today in Math Boost Camp, we are talking about conceptual understanding, how we build understanding, and how numbers have context, whether it's in the concrete, pictorial, or abstract stage of learning. Here we go. I know it's hard to believe that this is something that has been around for quite some time. Even though I graduated more than a decade ago, it's not something I learned. So I found it so amazing that this has been around since 1966. Jerome Bruner first wrote about the theory of instruction, which is what this was called at its origination in 1966. Now, even though the stages had different names, it was governed by the same rules and laws, forming and transforming the propositions within these stages. Now, it's all about the sequence of learning. This again was written about in 1981 and 1998 and is still being talked about today. But what's even better about talking about it is using it in your classroom. And that's what we're going to be talking about in today's session. So the first stage of learning is the concrete stage of learning. This is a very common practice in kindergarten, first grade, and second grade classrooms, but it loses its luster as students move through elementary school. It's very common to not have access to concrete materials or be in such a time crunch that we don't consider using the concrete experience in the classroom. So I want to share a little bit about what the concrete experience means in your classroom. Now, the concrete stage of learning is based on using activities, real life context, or manipulatives in the classroom. It is a big misnomer to just think that concrete means hands-on manipulatives. It could be an activity where the whole class is sharing and creating knowledge together, or it could be a real life context situation. If I'm a kindergarten teacher and my students love teddy bears, we might have a problem solving around teddy bears. If I'm an upper grades teacher and Fortnite is the hottest thing around, it might be a real life problem with that. It might be going to the pizza shop. It might be going to a donut shop. Something that the majority of your students, if not all of your students, can relate to in your classroom. Now, research has supported the use of the concrete stage, and it has thoroughly researched this. It's proven that this stage of learning helps students with disabilities, students who need remediation with deficits and computations. It helps students learn place value, fractions, algebra, and geometry, if not more. Those are the areas that are research-based that I've found. This stage like I said, is most commonly used with math manipulatives, but it could be used also with realia or real life objects that you bring into the classroom. So I want to show you, as we go through the different stages, I want to show you a practical example because we're talking about tools and techniques that you can use in your classroom. So for the concrete, I wrote out a problem. And now as you work through the progressions of these stages, you never lose the words. We always give the numbers a context because otherwise move sounds rude and it doesn't sound helpful. So we want to keep that in mind. So even when we're using hands-on manipulatives, I am still verbally giving the students the problem-solving situation, okay? So Katie ate 2 pizzas, Laura ate 3 pizzas. How many pizzas did they eat? Or how many pizzas did they eat altogether? So, for instance, if I was using this in a concrete way, I might actually use pizzas. So I might have Katie, a student in the classroom, holding up 2 pizzas. Sorry, you couldn't see. 2 pizzas. And I might have Laura, a student in the classroom, holding up 3 pizzas. These pizza plates were purchased at Hobby Lobby in their party section, and I just think that they have so many abilities to helping me in math instruction that I had to buy a set of large and small size plates. So Hobby Lobby, if you're curious. But by actually having the students hold up the realia or these paper plates, the concrete material, the students can have this application to the knowledge. In addition to doing this whole group, students can have counters at their tables or working in partners to actually make the problem-solving situation also, because we want it to be hands-on, okay? And when we do something as a whole group, we want to make sure we can also find something for the class to do also, so they're not off the hook and that they're engaged in the content as well. So the concrete example for a problem-solving situation is using the paper plates or the counters at their table. Now we're going to move into the pictorial stage. And the pictorial stage is also significant because it's the seeing stage. This is where the visual representations that you use of concrete objects are used to model problems. This stage of learning encourages students to make the mental connection between the physical object that they just handled and the abstract pictures, models, diagrams that represent the objects from the problem. Building or drawing the model makes it easy for students to grasp abstract concepts, for example, fractions. Simply put, this helps students visualize those problems and makes it more accessible to them. And this is helpful for all students, especially students with special needs or English language learners. So in this stage, we would actually move from the realia, the hands-on manipulatives, the concrete experience, into a picture. And so there's 2 things that I'm thinking about when I'm seeing this. And this might be an actual model drawing where Katie would have pizza and Laura would have pizza, but Katie's going to have 2 pizzas. Oh, sorry. I probably need to add my labels. Katie's pizzas and Laura's pizzas. Okay, so Katie has 2, so I draw 2 unit bars equal length. And then Laura has pizzas, 3. And then we are looking for the total, so we represent that with a question mark. If you are looking for more information on model drawing, I've actually recorded an additional video that's a supplement to this video that'll actually work through the 8-step process of model drawing. So make sure you check it out and you subscribe so you don't miss a video. So this is one example of a pictorial. You could also, I want to make sure I have enough space. You can simply just draw it out. So Katie has 2 pizzas and Laura has 3 pizzas, okay? And that is just another quick example of how you're taking it from the concrete to the pictorial stage, where students are modeling or sketching it out and visually seeing those images, okay? And again, you're still using the problem-solving context or situation as you're going through this stage of learning. And our final stage of learning is the abstract stage. And oftentimes this is called the end result. This is where we want our students to be at the end of the lesson or the end of the unit. Now, the abstract stage is the symbolic stage. This is where students use abstract symbols, to model the problems. Students will not progress to the stage until they've demonstrated that they have a solid understanding of concrete and pictorial stages of the problem. So if you see your students struggling, teacher tip, you always want to go back to the beginning and build them back up. Oftentimes, these are actually considered learning progressions. There's a lot of debate in the mathematical community if that's accurate or not. But a lot of times when you have students that are struggling, they just don't see it yet. And so moving back to the concrete or pictorial stage is very helpful. If you use pizza plates here, you might use counting bears or 10 frames. If you drew a model drawing, maybe just having simple pictures instead. So just thinking about showing students a different way or a different modality will ensure success as students move through the stages. So with the abstract stage, this involves the teacher introducing the actual mathematical symbols. And this is important even in kindergarten, even though it's not required in a lot of state standards, just so students can be familiar and know where they are headed. This also helps them, students that are ready for the challenge, they pick up on it. Students that are not ready for that challenge, they kind of miss that step. And that's okay. We just want them to know that this is where what we're building towards. So the abstract stage, quite simply, is just 2 plus 3 equals 5. Katie ate 2 pizzas, Laura ate 3 pizzas, and all together the girls have eaten 5 pizzas. And so that's just the symbolic representation. One thing I want to mention is that oftentimes the abstract or end result is what we see in a workbook. It's what we see on a test. It's a problem-solving problem that you do with problem of the day. It could be something very simple in an interactive math notebook when you have a word problem, okay? So this is the end result. It is very critical that I tell you this next thing because this is very, very common in elementary classrooms. Because of the lack of time, we tend to bypass the first 2 stages and go straight to the abstract. And you're doing your students a disservice when you skip those 2 steps. In the event that you do lose time and you have to go straight to the abstract, it is going to be critical that in your small group interventions or during guided math, that you go back to the concrete and pictorial stages with your students, because a lot of them will miss the conceptual understanding of the concept because they haven't done these 2 prior steps. So just please be mindful of that as you're curriculum planning for the new year. Also, as you're working with the CPA model or any mathematics, it is essential that students are communicating and sharing their knowledge with others. We want them to feel respected and valuable as we create a math-rich environment in our classroom. And we also respect that there are different ideas in the classroom and there is more, there is oftentimes where there is more than one acceptable strategy or even solution to a problem. So it's very important that we communicate and share. Just a reminder, you are a facilitator during this process. Oftentimes, you are a co-learner as well. You are assisting, helping, supporting, and providing feedback as these math concepts go through the different stages of learning. This is the concrete, pictorial, and abstract model. I hope that you will take these stages into careful consideration as you are planning your math instruction for this new year. Make sure that you have subscribed so you don't miss out on future videos. Thanks, y'all.